Good morning, everyone. Welcome to Mohammed and welcome to DevDays 2025 Day 2. We have with us Peter Groves-Williams for a beginner tutorial on Introduction to SNOMED Clinical Terms with FHIR. We have a room for some questions in between, so if you could type your questions in FHIR app, we can answer. Peter can answer that. And towards the end, there's a 5-minute question and answer time. So let's begin.
Thank you. Good morning. Welcome to this introductory tutorial for working with SNOMED CT together with FHIR. My name is Peter Groves-Williams, and I'm a technical specialist with SNOMED International. Full disclosure, I have given this talk at DevDays before, so I've got some flexibility to tweak how much time each topic gets. So I can adjust the parameters a little if we can play a game of raise your hand. Could you raise your hand if you speak English? Great, that is a prerequisite for this talk, unfortunately. Hands up if you're new to SNOMED. Not SNOMED, okay, so people know SNOMED. Hands up if you're new to FHIR. People know FHIR. Are you mostly here to find out about the LOINC and NUVA work that we've been doing to make those extensions available in SNOMED CT? No? All right, people just looking for a general refresher. Okay. And hands up if you've seen me give this talk before. Okay, fresh material, that's great. Well, for the LOINC and NUVA work, that is really what's new this year for SNOMED International. So I'll present that work and then do a little break for questions there, because that is quite a divergence from what we've done before. These are our learning objectives for today. If at the end of this presentation you feel you have not achieved these objectives, or if I have not explained them correctly, or if you would like more detail, please do come and find me anytime this week. Right, let's say you've landed on planet Earth and you're looking for some interoperability with the local life forms, and someone hands you a dictionary with phonetic pronunciations in it. Unless you've also been taught grammar, the structure of sentence, how a sentence needs a subject and a verb, maybe add in an adjective or two. Unless you also have that structure, your communication is not going to be understood. So for today's talk, the terminology is going to be SNOMED CT, and the information model will be FHIR. They work together, they complement each other. SNOMED and FHIR work best when they play to their strengths, and SNOMED acts as a controlled vocabulary and leverages the structure that's applied to it by FHIR. What is SNOMED CT? SNOMED is the most comprehensive and precise clinical terminology in the world. SNOMED is first and foremost an ontology, which means it's a set of concepts in a given subject area and the property and relationships between those concepts. SNOMED is a polyhierarchy or directed acyclic graph, so each concept can have many parents and be many types of thing at the same time, and this reflects how things are in the real world. So it's not a classification system like ICD, where ICD-10 I should say, where a code can only belong in one particular bucket. SNOMED CT has a comprehensive scope, which we'll see in the next slide. So there's the potential to record everything you need in an electronic health record with single terminology. It's computable for analytics and decision making, and that's particularly important when you need alerts in real time, as you would for something like pharmacovigilance. And because SNOMED CT is hierarchical, you can work at whatever level of granularity suits your use case, fine-grained detail for individual patient records, or with abstract-level groupers for population-level reporting. And it's self-describing. Most things in SNOMED CT are concepts, the different types of descriptions, the attribute types, even the structure of the reference sets themselves are described using SNOMED codes. Also, the rules that say which attributes can be used in which domains, those are defined using a machine-readable concept model. So here's a breakdown of the SNOMED content. We're at 374,000 active concepts in the international edition as of June this year. It's over 500,000 if you include inactive concepts, which is of course very much still relevant if you're working on analytics with patient records. We publish a new edition on the 1st of every month, and we'll add about 800 new concepts each time. Member countries will produce extensions to the international edition, so some of them just add translations to the descriptions. Other countries add concepts that are specific to their jurisdiction. The UK, for example, almost doubles the size of SNOMED CT from the international edition. So about a third of SNOMED CT is clinical findings, which is disorders, or we'd use the condition resource to describe those in FHIR. And after that, procedures, body structures, organisms and substances we would call a foundational sub-hierarchy. They support some of the other hierarchies. Now, when we come to talk about the LOINC extension, those codes are observable entities in SNOMED, and that's the first dark green bar there that doesn't have a number against it. So slightly less than 3% of all SNOMED concepts. But when we add in the LOINC extension into the mix, that's about 35,000 concepts, and that will bring it up to nearly 10% of the international content. Right, let's look at the logical structure of SNOMED CT. Everything in SNOMED is a type of component. So they all have unique identifiers, effective times, which change every time they are updated. An active flag, nothing is ever deleted in SNOMED. We will just mark it as inactive and it will remain available. And it belongs in a particular module. We also have reference set members. Those are again components, but they use UUIDs for other identifiers, not SNOMED identifiers. You maybe see from the cardinality, each concept there will have at least 2 descriptions, and a concept must have at least one relationship saying what its parent is. So relationships join the source to the destination with a specific type of relationship. Component is an abstract class. We don't actually instantiate those. Everything is either a description concept relationship or a ref set member. Attributes. This is what appendectomy looks like in a model diagram, and there's all sorts of detail in here which you would learn about if you did one of our foundation courses. There's the name of this concept is excision of appendix. That's not the preferred term. We put the fully specified name there. It's unambiguous. No other concept will have that same name. And there's also a semantic tag in brackets there. That one is procedure. And that does help because sometimes the same word will appear in multiple hierarchies. Clinicians do like to reuse the same terminology in different disciplines. The 3 lines in the circle on the left there show that this concept is sufficiently defined in a logical sense. And what that means is if there is any other concept which has these 2 same relationships grouped together, procedure site to appendix structure and method to excision, that will become a type of excision of appendix when we run it through a classifier, which is a computer program that makes inferences depending on the logical statements that you've made. The other 2 purple boxes there are the parents, and those are purple and they have a double line around them to show that those are also sufficiently defined. The blue boxes are primitive content. And the open white circle there shows that those 2 relationships have been grouped together. So you can have groups of attributes and say there was a morphology, we would group that with a particular body site, and some other feature could be grouped with a separate body structure. So that covers our first 2 learning objectives. Moving on to the third, as well as the concepts themselves, SNOMED defines a family of languages, and these build on each other successively. So SNOMED compositional grammar is how we would describe a concept. It allows you to very concisely show the modeling of a concept, and either using pre-coordination, which is where we've published the concept, or post-coordination, where you can construct a new concept at runtime. So then SNOMED compositional grammar is used in expression constraint language, ECL, which I'm going to speak about in quite a lot of detail, and it's going to be very useful for working with value sets in FHIR. And then ECL is in turn used in SNOMED template language, where we show how a particular concept in a domain should be put together, the different attributes that it can take, and those have slots that can be filled in with a constrained set of concepts. So expression constraint language is, I think, the most powerful feature of SNOMED CT. ECL gets used all over the place in SNOMED, in our template language, our machine-readable concept model, in reporting, in our specification of ref sets, and we'll see shortly how it can also be used directly in FHIR value sets. The table here shows the symbols that we use 95% of the time. There are other operators for ancestors, immediate parent-child, a reverse operator, and cardinality, documentation for which can be found in SNOMED's document library. Where the descendants operator is useful for the maintenance of FHIR value sets is, if some new concept gets added into a sub-hierarchy that we're interested in, we can just pick that up without needing to explicitly redefine and upload a new value set. The caret or hat symbol is particularly useful for FHIR value sets because if we have some existing set of SNOMED content in a ref set, we can just define our value set to be the members of that ref set. So we only need to maintain that list in one place, and it will be updated automatically from one to the other. Here's an example of some ECL. Right to left, I'm saying I'd like all the descendants of medicinal product. When I see a colon, in my head I say where there is some sort of has ingredient that is exactly caffeine. So ingredient could be has ingredient, or there's another attribute which is a child of that one called has specific ingredient, has precise ingredient. And I've also asked for a presentation strength denominator value to make sure that I get a concept back that I could actually prescribe and not some abstract grouper that would align with a more abstract level, say in ISO, IDMP. The descriptions between the pipe symbols are optional. They're human readable, and those of us who don't memorize 10-digit numbers for fun like to see them in there. But we probably wouldn't transmit them over a URL or something like that where it's not necessary. Right, before I talk about LOINC, NUVA, and NPU, I'd like to show you everyone's favorite slide of the year. I pinched this one from someone else's presentation, and it's been pinched for me. It was shown in Madrid at the event there we had a few weeks ago. So SNOMED International collaborates with a lot of other organizations. And in particular, in our 5-year strategy, SNOMED is acting as a terminology hub, an integrator for other terminologies. And we're going to look at that green box down there at the bottom, where we're presenting other companies' work in an alternative structure. They will very much retain the intellectual property, and they will even publish this work. But what we're doing is taking their content and presenting it in a SNOMED-compatible format. So here's what we've been working on. The LOINC ontology extension was published back in March, and Regan Streif did a great presentation video, which is available at the LOINC SNOMED website there. NUVA is a vaccine ontology, which came out more recently. In the middle of May, we had a launch event in Bordeaux, and we are still working on NPU, which is an early pre-runner to LOINC, actually. They split off quite early on in their development, and NPU is in use in Scandinavian countries. So where NUVA is particularly interesting is in the SNOMED medicinal products hierarchy. We don't include any brand name drugs because those vary from country to country. We only describe generic drugs. But NUVA is tracking vaccines in use all over the world. So when we add the NUVA extension, we're providing a code that can be recorded directly into a patient's health record. And NUVA is a solid ontology in its own right. It's distributed as a single RDF file of relationships between the various entities, which is an industry standard and could be loaded into a classification tool like Protégé. But here's the thing, even if the format is standard, what are the semantics? How do I work out which of those objects represents a vaccine? What display terms should be used? Should I look at the label, the pref label, or comment? LOINC, of course, does make itself available as a FHIR package, but what if you're in a country or communicating with a country that doesn't use LOINC, like the UK? By making these other code systems available in a SNOMED format, we reduce the burden on implementers to learn a new file format and semantics, and hopefully provide for transparent interoperability. So here's what the LOINC concept looks like when it's transformed into a SNOMED concept. The 5 or 6 parts that make up a LOINC concept are mapped to SNOMED attributes, and then the preferred name of each of those parts is fed into a template which forms the fully specified name. And the point we'd like to stress is that this is not a map from a concept in one system to a concept in another. This is exactly the same logical entity expressed in an alternate format using dual identifiers. And here's a NUVA example. Again, dual-coded identifiers, but you can see that coming together of the SNOMED modeling and NUVA. Has active ingredient is inherited from our medicinal product hierarchy, whereas has valence is unique to NUVA. Valence isn't a concept we knew about at all in SNOMED CT, and so that is coming through there, and those two are sort of merging together. And I hope that there will be closer alignment of those two models in the future. And here, this was a large part of the point of this slide, was to see the branded drugs as children of that more abstract concept. So this isn't a map, and if NUVA were to add a new vaccine, an automatic pipeline would take in all the labels and relationships relating to that new NUVA concept and create a corresponding SNOMED concept. Okay, so that's really what's new in SNOMED for this year. We can take any questions on that specifically now if anyone has them.
We have one question from a participant. How do you use expression clinical language in IG authoring? Tools like IG Publisher and Sushi do not support ECL. Expression constraints language, sorry.
Well, tx.fhir.org does not support ECL, is a large part of the problem. And Graham has come to us and asked us to make Snowstorm, which I will talk about next, pass all the validation that is required to become a more useful terminology server. Because SNOMED International has access to all of these country extensions, and really we should be the authoritative source for that. So particularly this year, and like as of this week, I'm working on a project to pass all those tests so that we can take over that burden of maintaining all of these extensions from Graham's server and bring them into the main SNOMED CT browser. And at that point, we can become the authoritative source for all of these extensions. And because Snowstorm and Onto server, of course, do support ECL, we'll be able to be more useful in tooling. Whether Sushi will be able to make use of that directly, I couldn't say. But hopefully, at least when the infrastructure is in place, then the tooling can move on towards that as well. Okay, any other questions on that? Or we can move on? This, for me, this is the holy grail of where we want to go with this, how these concepts will be used together. So here we're saying, I have a patient who's received an immunization program, and we're saying exactly that one product, Tetravax, that product has these dual codes. In NUVA, the VAC0086 and the SNOMED code, one and the same thing. So that's SNOMED CT as a logical model, as a set of languages, and how it's been used to offer alternate representations of other code systems. In terms of our software support for FHIR, we've also made a terminology server available as an open source project available in GitHub, and it's written in Java, Spring, and Elasticsearch. Snowstorm is not a commercial product, although we do try to react quickly to issues raised on GitHub, and it's also available in a Docker container. Snowstorm's FHIR API is based on the Happy library, so pretty much anything you can load with Happy you can put into Snowstorm. Snowstorm X is, as you might guess, the experimental arm of Snowstorm, and we're trying out support for post-coordinated expressions there. Snowstorm Lite is a cut-down version of Snowstorm with a low memory footprint, and I think it will host a country extension read-only in about 4 gig of memory. Snowstorm provides the back-end data store and business rules for a lot of our applications. Here you can see the authoring platform that clinical terminologists use to maintain the ontology. And this is a good place to tell you about concrete values. This is probably too small to read, but concrete values allow you to describe relationships to not just other concepts, but also to numbers and strings. So instead of creating a concept to represent a number, we define a concrete value there, and that will let you use that directly. And that's really useful for being able to do comparative ECL. So we can say things like, show me all of the medicinal products that have more than one ingredient, or show me all the medicinal products that contain aspirin at a strength of less than 100 milligrams, which might be useful if you were looking for blood thinners. Okay, that concludes everything I wanted to say as an introduction to SNOMED, and that was about a week's worth of foundation material condensed into 15 minutes, so congratulations. I'd now like to turn to FHIR, and specifically to using FHIR in relationship with SNOMED CT. Here are the main FHIR terminology resources we're going to look at today, and each one of those has a number of operations that can be performed on them. I'll just pick the ones that have particular features that we can take advantage of when we're working with SNOMED CT. Code system lookup operation. Here what we're saying is, I've got this SNOMED code, tell me more about it. So specifying the code and the URI for SNOMED CT in the parameter, and I've also asked for a specific module and version of SNOMED there, and we'll get back a default set of properties for that specific code. But I'm also requesting an additional property. The FHIR specification links to a page listing particular properties that have been requested on SNOMED concepts. The module ID, whether the concept is sufficiently defined in a logical sense. But the most interesting property is the normal form there, which allows you in FHIR to see the attributes that have been modeled. So this just pulling out the whole return is much larger than this, but just pulling out these two sections. Here you can see, and this is using SNOMED compositional grammar, that the tetanus toxoid vaccine is defined as playing a role, and the curly braces there shows that these two attributes are grouped together, has the valence of tetanus immunoglobulin, and has a valence of tetanus toxoid. And the other property that's coming back, because I can't overstate this enough, this is not a map, this is a property of that actual entity, is the NUVA concept code. So that's one way of getting it back, and we'll look at another in a minute. So the translate operation would normally allow you to map from one code system to another. In this case, this is actually happening, but we've very recently, just in the last few weeks, defined a URI there that says equivalent concept. In SNOMED CT, we would call this an alternate identifier, but we workshopped that a bit between Graham and the SNOMED on FHIR working group and came up with equivalent concept. So that will give you back from the SNOMED code what is the NUVA code. Now, in a map, normally the FHIR CM, we would give the reference set, the concept that represents that map. And one of the features of using a specific string like equivalent concept is if we ever get to the point in the future where NPU and LOINC align their models so that we could actually have one and the same entity appearing in SNOMED, then all three code systems will be aligned. The SNOMED concept will also be, the LOINC concept will also be the NUVA one. At that point, we can miss out the target system and just say, for this SNOMED code, show me the equivalent concepts, and we would get back both the LOINC and the NPU codes there, which would really be interoperable. That's very exciting. So something that is in the heart of FHIR is that a SNOMED concept is a SNOMED concept. It doesn't worry about modules, where those live, what extensions they belong to. If you're a SNOMED code, you're a SNOMED code. And we've taken that to heart in our URI specification. So URIs are just set strings. They don't have to go somewhere. But I think it's good manners when you've got something that looks like a URL that will resolve. And so wherever that SNOMED code is, if we know about it, we will present that to you in whatever format you are working with. So depending on your HTTP headers that you pass through. If you're in a browser, you'll get a browser view. If you're coming from FHIR asking for a JSON object, you'll get one of those back. Or you can force the format there, which we pinch from the FHIR specification. So if I was to click through on that, it would work out that this concept, let's do it now. So that would find that concept in the United States edition, and that is American cheese. Okay. Right, value set expansion. That is, ask the server to evaluate whatever content or rules the compose element states against a particular instance of a code system and list all the codes that satisfy those rules. So I'd like to focus on a particular strength of SNOMED CT, which is in internationalization and multi-language support. You can see here that I've told the server to ignore whatever code system is specified in the value set and force it to be, in this case, the Swedish module. And because I haven't specified an effective time, we're going to get back the most recent release. And I want the preferred term to come back, the display term, to come back Swedish by preference, and if not, fall back to English if it doesn't exist. I'm also going to filter for the word pollen. So if I click through on that link and scroll down, we can see those are all the Swedish preferred terms that match that value set. Right, implicit value sets. This is, in my mind, the coolest feature of FHIR because it uses my favorite feature of SNOMED CT, which is ECL. So here I have an ECL where I'm saying there's the hat operator. So I want everything that is a type of LOINC orderable, and where the direct site is some sort of blood specimen. And there's the URL that I would construct for that. I say I want a value set which uses, I can't put the hat symbol directly into a URL. I have to URL encode that. That's why you see a 5e there. But if I click through on that, I would get back 991 concepts, which is too many to display. So the clinician, let's say it's Dr. House. Dr. House suspects that the patient has got propane poisoning, and so he's going to start typing their PROP. And when we click that through, make that a little bigger, then we're going to get back these are really LOINC concepts, although they have SNOMED codes there's propane there and the other prop concepts. So where all this SNOMED and FHIR is getting to is how are you going to make your medical application responsive, context sensitive, and therefore clinically safe. So we've written a demo application that showcases some best practices, and you can find that at snomed.org/UI. I've tried this as a live demo, and it's just too small to read, so you're welcome to try this out in your own time. The main thing I'm showing you here is that I've opened up the developer's tools console so you can see the API calls being made. And what happens when you start typing into a procedure box is that a FHIR value set expand call gets made, not to a predefined value set, but to an implicit one using ECL that says, return me concepts that are a type of procedure, and filter that list with whatever I've started typing into the box. So that reduces your maintenance overhead because as you update SNOMED, you automatically pick up new procedures without having to redefine your value set. And it keeps it safe because you're only showing concepts that are appropriate to that field, not all of SNOMED. And it keeps it performant because we're filtering down that list as the user starts typing. So you're not scrolling through 1,000 concepts to find what you're looking for. You can see that the laterality field there has been grayed out. And that's because your appendix, you don't have a left appendix. So SNOMED CT in its concept model knows that and disables that box. You cannot lateralize that concept. And so that protects the user from miskeying. And there's a drop-down top right that allows you to select the server. And that really shows you the industry standard nature of FHIR, that you could drop in any other terminology server and it would behave almost exactly the same. The content you get back might be slightly different. Here I'm hitting onto server, so I'll get back Australian concepts if there are any in addition to the international concept. And also, because my browser at the time was set to British English, I got a preferred term back of appendicectomy, not appendectomy. Okay, so there is our learning objectives once again. The main message I'd like you to take away is that SNOMED and FHIR need each other to communicate meaning. A controlled, precise terminology combined with a universally agreed information model. Also, that there are specific features of SNOMED CT that we can take advantage of in FHIR to reduce the maintenance of value sets, provide context-sensitive sets based on both a position in the hierarchy and specific attributes using ECL. So working towards the last couple of slides now, just a shout out to our SNOMED on FHIR working group, which is coming up for being 10 years old now. This was created at the request of members, and we meet at a very reasonable time in the US afternoon on a Tuesday, very unfashionably early if you're in Australia. And to make that meeting more accessible to Europe and Asia, we also run a call every 4th Wednesday at 10:00 hours. And we have some great experts who join in that discussion. So you're welcome to join that anytime as a drop-in. Okay, that is us for today. Can I take any questions?
It's a bit tough to phrase that question. I wonder, do you have a recommendation for a reference architecture, for example, how to combine a FHIR server that somehow stores some patient data that our clinical application requires, but somehow how to bring all these features that you showed with the Snowstorm to this server? So we were struggling with this and couldn't find a good solution. Do you have recommendations for that?
Only at the very highest level, which is that a terminology server is normally distinct, and you would farm out any terminology requests to it, let it do its own thing, and don't try and confuse those things. And the other thing is that a terminology server can be built off the shelf. You don't need to invent one. This work, it's a lot of work, has been done for you in several places. So make your calls out to the terminology server using ECL if it supports it, because I love it, and work with it that way. I can see that doesn't solve your problem, I'm sure, but that's as much as I could tell you.
Anyone else?
Okay, we're done. Right, thank you very much, everyone.
Thanks.